Hi, my name is Doug Higgins, and I'm a graduate research assistant in Dr. Mary Hosbeck's lab at Michigan State University. I'm a PhD candidate working on my degree in plant pathology. The major foliar diseases in Michigan onion production have historically included purple blotch and botrytis leaf blight. Now, downy mildew can be a problem from year to year, but really with the right fungicide program, this disease can be well managed. A few years back, there were a new set of foliar symptoms showing up on onions that kind of included these diamond-shaped tan lesions. You know, at the time, people weren't really sure what was causing these symptoms, and the Hosbeck lab actually worked to figure out and link these symptoms to a pathogen called Calotoxicum cucoides. And then they also proceeded to do some fungicide efficacy work that's really the basis for our management program that keeps this disease at bay. And so bacterial leaf blight is a major problem for onion growers in Michigan. It's a major foliar disease issue, and it continues to be a major issue. It's caused by Pantonium agglomerans. Symptoms of this disease include these tan, kind of necrotic lesions that run down the onion leaf. They have these water-soaked areas throughout the symptomatic tissue and kind of where the leaf connects to the bulb. The thing about bacterial leaf blight is that it's vectored by thrips. And so really management of this disease is really done by keeping and managing thrip populations in the field. Now, the other major foliar disease that Michigan onion growers contend with is Staphylium leaf blight. And that's what I'd like to talk with you about today. Now, Staphylium leaf blight, similar to bacterial leaf blight, causes this kind of premature senescence or early dying of the onion leaves. And, growers will tell you that these onions are dying with their boots on. And that means that they're dying, they're not lodging as they're supposed to, they're not reaching their full development. And they're also losing green tissue, or photosynthetic area, they're losing that early. And so what that results in is the reduced bulb yield, and maybe even reduced bulb sizes. Okay, so symptoms of Staphylium include oval tan lesions. They start out as oval tan lesions, and then they really progress as this lesion that kind of runs down the leaf of the onion. If we were to look at this under the microscope and zoom in, we would see a bunch of spores just covering the dark surface here on these onions. This disease can cause some tip burn back, and it really kind of just runs down from there. So today what I'd like to do is share with you some of the research we've been doing on Staphylium. Last year we started working on some efficacy trials for different fungicides. And this year we've really taken some of that efficacy work and expanded on it and looked at some questions that involved when to time the fungicide applications, when to initiate a fungicide application, and how often to spray the fungicides. So let's go take a look at the field plots, and I'll show you what we've been working on. Okay, so here we are at one of the replicates of our fungicide initiation experiment. Both of the experiments that we're going to look at today were done with our grower cooperator. So using commercial standard production practices. These are all done with a storage onion, Bradley. This treatment that we're standing in front of, I picked out a single rep out of the experiment to share with you today. We have several treatments in this experiment, and they all involve on when to start the fungicide application. So what we did was we started fungicide application programs based on different growth stages of the onion. So when the onion was at 3 to 4 leaf, we started a set of fungicide applications. When it was at 5 to 7, 8 to 12, and then 2 different bulb stages. And then after our fungicide program was initiated, we continued that program on a 7-day application schedule. In this experiment, we tested 2 different fungicide programs. The first program consisted of alternations of Luna Tranquility, alternated with Tilt plus Bravo Weather Stick, alternated with Omega, alternated with Miravis Prime, alternated with Aprovia Top. In the second program, we applied Bravo Weather Stick alone, alternated with Tilt applied alone, alternated with Luna Tranquility, alternated with Miravis Prime. Okay, so the first place we'll start is in the untreated control. This is treatment that received no fungicide protection. And as we look at these onions, as the growers would say to me, they died with their boots on. So they died, what they mean is that they died standing up. They didn't end up lodging. We can see at this point of the season, most of the green tissue is almost completely gone. And really, this disease is, has taken over this plot. Okay, so here we are in front of the program 1 that was applied at our earliest growth stage, which was a 3 to 4 leaf stage. And this plot, as you can see, is that the foliage is still pretty green. Some of the onions are starting to lodge or fall over, in contrast to the untreated that we just saw. And then right next door, we also have program 1 applied at the 5 to 7 leaf stage. Now this is about 2 weeks later, and it's pretty comparable in terms of percent green area of these onions. And so the differences between these two treatments, we'll have to see how they shake out statistically, but they're going to be pretty close. Now this treatment here is our second program. Remember, we tested 2 different programs. This is the second program that was started at the 5 to 7 leaf stage, and it does not look that different. It does not look different from the program 1. So program 1 and 2 in this trial are performing very similar to each other. So here we are, program 1 applied at our next growth stage, 8 to 12 leaves. We see a noticeable difference in the percent green tissue in this plot compared to our 2 other earlier treatments. So here's bulb stage 2.5 to 4 centimeters. So fungicides initiated when the bulbs measure 2.5 to 4 centimeters in diameter. And so this stage, we still have some green left in this plot. It's fairly comparable to our 8 to 12 stage treatment. Okay, this treatment here is the 4 to 7 centimeter bulb treatment, meaning that the fungicide initiation sprays started when the bulbs were 4 to 7 centimeters in size. And we could see, based on the amount of green foliage that's left in this plot, that this might be too late to start your fungicide applications. Now we still have yield data to go through, but in terms of we look at the percent green tissue left on these plants, they definitely lost their tissue earlier than our earlier fungicide treatments that started at the 3 to 4 or 5 to 7 leaf stage. We see that these onions, again, are dying with their boots on, so they're dying standing up, and they haven't lodged. Okay, so here we are in one of the replicates of our second experiment. Now in this experiment, what we wanted to look at was how often we should apply the fungicides. So some of the treatments that we tested were a 7-day application interval, a 10-day application interval, a 14-day application interval, and then we used the disease prediction tool called Tomcast, which was developed for Alternaria on tomatoes. And we set a threshold of 15 disease severity value and 20 disease severity value, or DSV. And so when the forecasting system hit this threshold level, that indicated that we should spray. So we waited until that happened. So what I'm standing in front of right here, this is the untreated control plot. Pretty similar as what we saw in the previous experiment. We don't have a lot of green tissue left here. None of these onions lodged over. And so this was the untreated control for this experiment. Okay, so this is the 7-day application interval. So fungicide programs, we tested again 2 fungicide programs as I described earlier. Both of the fungicide programs were fairly comparable to each other. And so we're looking at right here in front of us just the program one. In terms of comparable, I mean comparable in terms of level of disease control and percent green tissue left. In this treatment here at the 7-day interval, we see that these onions are lodging and they still retaining some green tissue and really looking how we'd like to see our onions look at this time of year, starting to tip over while still remaining green and not die out. So let's go take a look at the 10-day application interval. Okay, so this is fungicides applied at 10-day intervals. There's a little less green tissue in this plot compared to the 7-day interval. Let's see how that works out on the statistical end, and also in terms of yield size, but a little less green tissue in the 10-day, but not by much compared to the 7, almost pretty close to the 7 and the 10-day application intervals. Let's take a look at the 14-day application interval next. Okay, here's the 14-day application interval. Significantly less green tissue left in this plot compared to the 10 and the 7-day interval. So 14 is stretching the application too thin. We need to be applying at the 7 to 10-day range here, and 14 is too long between application intervals, at least to protect the amount of green tissue that should be left at this point of the season. So let's take a look at how our disease severity, our disease prediction system worked out. Okay, so here we're in front of the 15 DSV's spray timing. So when our Tomcast model hit 15 disease severity values, we would initiate a spray. Now, as you can see from this plot and next to me at the 20 DSV, was that the fungicide prediction timing doesn't appear to be working very well. There's not a lot of green tissue left in either one of these plots at this point. One of the things that appeared to happen was that we didn't get a lot of rain this season, and when we did get moisture, it occurred overnight as dew. But it also occurred with the model averaged some pretty low temperatures overnight, and it failed to accumulate high disease severity values. So we didn't get very many sprays initiated for either one of these plots, and as a result, we can see that we lost a lot of green tissue in these plots. And when we waited long application timing intervals between fungicide applications. So as kind of a preliminary summary of what we're seeing out here in the field, now I'm just going to preference this summary with that, I'm showing you these field plots, as they're starting to wrap up, but we still need to summarize these disease ratings and really run that statistical analysis. And we also need to we're going to take some yield data on these plots to see if what we're seeing in terms of decreases in green area are related to losses in yield, whether that be in the weight of the yield or even in the size of the bulbs. And so what we're starting to see from this research, though, which we will confirm when we run the statistics and see how it shakes out, was that really that initiating fungicide programs early at that 3 to 4, 5 to 7 leaf stage probably is going to be the most effective strategy at keeping the percentage of that onion green as long as possible. And then applying these fungicides at 7, maybe 10, let's see, day intervals would provide good control. And between the two programs that we looked at this point, it's hard to say if there's going to be statistical differences between those two fungicide programs. They seem awfully close in a lot of instances at the same initiation or the same application timing. There might be some subtle differences in there to have to check out, but that's kind of the trend that we're seeing here in the season. I guess I wanted to point out that both of those fungicide programs, are involving systemic fungicides right from the get-go, instead of relying on a multi-site early and saving the systemic for later. And we have other research that, I didn't get to share with you that looks a little bit more specifically at that question. So maybe tune in to the Great Lakes Expo, put a plug in for that, take a look at some of the other research that we've also done with this in these Symphylium plots. And so with that, I'll turn it over. I guess, at this point, we'll take questions if there are any.